Decisions. You make them every day. Some big, some small. But some decisions matter more than others. Some decisions impact thousands, even millions of lives. Real families, real communities. In those kinds of decisions, the complex ones that matter most, those are the ones you've got to get right. That's where Gurobi comes in. With Gurobi's decision intelligence technology, you input details about your complex business challenge, and Gurobi's AI outputs a detailed action plan. It's how the world's leading global organizations make fast, confident, unbiased business decisions every day, even amid rapid change and global disruption. Gurobi customers power the world while minimizing environmental impact, get people where they want to go as efficiently as possible, maximize investor returns while minimizing risk, deliver the right products into the right hands at the right cost, and create the most exhilarating events while reaching the broadest audience. With Gurobi, you too can tackle your most complex business challenges with confidence. Better decision-making starts here. Gurobi, the leader in decision intelligence technology.
Hi everyone, I'm Marie, your event host, and I'm truly honored to be part of today's webinar. A warm welcome to all of you as we explore tackling the global challenge in empty container repositioning. We appreciate that you're taking the time out of your busy schedule to join us. So in this session, learn how Gurobi and TetriXX explore how data-first strategies, predictive modeling, and advanced optimization can transform empty container repositioning into competitive advantage. But before we begin, I'd like to go over some housekeeping rules. So the session will run for about 30 minutes to 45 minutes for the discussion and 15 minutes for our Q&A. And participants will remain muted and your cameras are all turned off to ensure a smooth experience. And if your connection stops, just log off and log back in to rejoin. Feel free to submit any question during the presentation using our Q&A function on your screen. And this webinar is being recorded and a copy will be shared to the registered attendees afterwards. So thank you for your cooperation and let's make this engaging and insightful session. And now it's my pleasure to introduce our speaker for today. Please welcome Jean Herbiere, Chief Data and AI Officer at TetriXX. So Sean has a deep experience in leading AI-powered optimization projects, helping global logistic companies build smarter and more resilient container system. So without much further ado, please, I hand over the floor now to Sean. The virtual floor is yours.
Thank you, Mary, for this introduction. Thank you, Gurobi, for creating this webinar. And of course, thank you to the audience that took the time to come and share a few minutes with us. I'm going to now share my screen. We're on the first page. So thank you very much for coming today. My name is Jean. I work for TetriXX, a startup located in Singapore. We specialize in data and AI in the world of the supply chain. Today, we'll want to discuss about ECR, empty container repositioning, and how we can tackling this global challenge. And for some of you in the audience, it might be something new. For some of you, you will be very specialized in data engineering. Some of you will know a lot about supply chain. So I'm really looking forward presenting this slide to you, and maybe have some Q&A at the end. I would like to thank Gurobi first to be a loyal partner for research and development and for hosting this webinar. Also, a smaller warning during presentation today. I'm talking a lot about shipping lines. There are more than 100 shipping lines in the world today. 20 of them I think represent 90% of the market. It's quite difficult to make a generality out of them. Some of them are very advanced in terms of data. Some of them are not so advanced. So I will try not to make generalities all the time, and please forgive me for that. When I actually try to explain empty container repositioning, I need to do a small introduction on global trade and the world of manufacturing we are living in. And usually I take a small example, and usually I mention about my shirt. I wear shirt every day to go to work, and the shirt that actually I bought in America a few years ago during one of my business trips in New York. In order to develop on how my shirt came to life, I think some of you know that there are few countries today that are cotton producers. One of them is the United States. So cotton is actually cultivated in America, and large quantity of cotton are actually put in a container. And this container will cross the Atlantic Ocean, at the moment going through the Cape of Good Hope, in order to reach some port in India, let's say, where very close to some factories that are specialized into transforming this raw cotton into a roll of fabrics. Later on, this row of fabrics will have to travel to a place where factories are actually specialized in making shirts. A lot of them are in Bangladesh. So if you look at your Gap shirt, if you look at your collar, you will see made in Bangladesh. Also, a lot of made in Vietnam. This is where a lot of manufacturing is done. Another point actually is Europe became pretty good at collecting recycled material coming from plastic, coming from metal, but Europe sometimes lacks the capability of transforming this raw material. So a lot of recycled products are actually shipped from Europe to China, let's say, where actually from this recycled material we'll make some buttons for the shirts. A little bit later, these buttons will move in a container again from China, along with other accessories, to Bangladesh, where in a factory my shirt will be, let's say, assembled. And finally, my shirt will actually travel back to America to be sold in a shop in New York. So the component of my shirt actually travel more than 50,000 kilometers. They cross the Atlantic Ocean and the Indian Ocean several times. It's pretty impressive, just for me to be able to buy a shirt. This is the world we are living in, and we are living in. And that's only made possible by the shipping industry that has an armada of ships, vessels that are constantly at sea. Some of the ships carry 100 containers. Some of them actually some of them contain apologize, there's been something blocking in my presentation. I think we should be good now. Apologize. Technology. Thank you for your patience. Some of the vessels are actually pretty impressive. They can carry 25,000 containers. Some of them, some lengths of some of the ships are actually longer than the Eiffel Tower. It's very, very impressive. They are constantly at sea, carrying carrying our goods issued from the manufacturing. So the only condition for this shared journey to happen is in order to transport the material would be to have an empty container at the right time, at the correct location, somewhere in the world to be able to transport either my goods or my raw material. And shipping lines are here to provide these transportation services from a point A to a point B. But they can only do it if they can have an empty container in order to fill it with goods. Today, we're going to try to see how they operate and why empty container repositioning could be an issue, what are the solutions, and what do we do at TetriXX with the help of Gurobi to do it. We're going to try to diagnose the root causes of the container imbalance, a small word, very small word on the tariff war strategies, and how we simulate a scenario and then we optimize. Empty container repositioning definition, the logistical process of moving empty shipping container from a surplus area, import heavy, to deficit area, export heavy. I think if we want to understand a bit the scale of the problem of repositioning, we need to look at the imbalance of a global trade, which is quite actually can be summed up in one sentence: is Asia export more manufactured goods than the rest of the world. If we look at a simple diagram for the US trade balance, you will see in the red part here what is imported, for example, from the Pacific region, and what actually US is exporting in the Pacific region. And you can see immediately through data visualization that there is an imbalance. So all my containers are arriving full of goods in the different American ports, but there are not as many that are leaving with goods. So what do we do with all this surplus of empty containers when actually these empty containers are needed somewhere else in the world, in Asia or elsewhere, in order to be able to be filled with goods and to be transported? Let's look at bits of numbers. We're going to look at, in terms of million of 20 equivalent units. Standard container size will be 20. You can see, for example, from America, 24 millions in import versus 6.8 for the export. And this is something that we see at different places, of course, this imbalance in the world, which is also quite interesting. And this is where we actually did our proof of concept the first time on our algorithm, is intra-Asia, between the different ports of Asia. We already have quite a high volume of TEU exchange. So this is definitely a place where we're going to have to deal with the repositioning of empty containers. Let's have a look at a little bit of the scales of the problem, other numbers. The cost of empty container repositioning for the shipping line, the money they spend to move an empty container at the place they need to have one, is between 16 to $20 billion. And it represents 5 to 8% of the carrier operating costs. We don't know exactly. It really depends how the audit and the finance is done in the company, but you can really see already the scale of the problem. Now, the volume of empty moves, I may say, is actually pretty large. It's 20 to 28 of the total sea container volume, and it's growing. We have more and more empty containers that we need to move from one point to another. Actually, it's growing faster than the laden move. impact on shippers. If you actually have to reposition all the time and spend money to reposition your container all the time, you have to spend more money, and your freight rates are actually increasing. And you have to also to calculate this delicate dilemma, which is cost of waiting. Let's leave a container where it is right now in this port somewhere in the world, because I believe at some point some merchandise will come, I will be able to fill it and to move it, versus let's take this empty container right now, even if it costs me money, and let's bring it to a port where I can do where I can fill it with good, I'm sure, and make good use of it. And just to finish on the scale of the problem, we believe that the shipping industry and the moving of boats is responsible for 2 to 4% of the total global CO2 emission. So whatever we do as scientists, as engineers, to actually reduce that, it's a gift to the world. Let's have a look to the key driver of the need of empty container repositioning. There are at the moment 170 million roughly of 20 equivalent units in active use everywhere in the world. It's a huge number of containers everywhere around the planet. And the trade imbalances that we see today are persistent. It's the nature of the world we are actually living in. The global supply chain nature is like we put the production at different parts of the planet. For the manufacturing, a lot in Asia, but we consume these goods everywhere. We also became very good at transporting goods, dry goods, also refrigerated goods. So we have different types of containers that needs to be taken into account. That also creates some discrepancy in the location of empty containers. There are specific demand, different customer, all these company ordering containers. And also the fact that it's not tackled maybe properly is because it's a non-revenue operation. It's costing the company between 8 and 15% of the OPEX just to reposition the container. And those are not very interesting when you just have to pay for something and it doesn't generate any money directly. Let's look at the challenges for the shipping line to reposition their assets. Forecasting difficulty is, I think, is one of them. It's quite an important one. How to predict the container demand when you have thousands of different locations to deal with. How actually to predict, even based on historical data, it's quite difficult to know where to position potentially. So today, some of the forecasting is actually done very manually, based on habit. Simple example, I know that it's soon durian season in Singapore, so I better stock some empty containers in Bangkok in order to bring enough durian to Singapore to it. Seems funny, but actually that's true. People do kind of an estimation, not always a very modern one. The second challenge is not all is pure data. If you decide of repositioning containers and you put them on a boat to relocate from Bangkok to Singapore some containers, if you make a mistake and you believe you could have done something better by relocating this container somewhere else, it's too late. It's going to take days before it reaches Singapore. So you have to wait. So the repositioning link time is quite different than just a calculation on a computer. The timeline creates imbalances, and there is nothing you can do. It's a very physical problem. The boat takes time to move from one location to another. Lack of visibility and coordination. Information could be quite siloed, or it could be from the different infrastructure we are dealing with. It could be a port, it could be a shipping line, it could be a container provider, it could be a truck service. All these different players in the world don't really share information for commercial reasons. They are very protective, or just for lack of data transparency, or all systems. There are plenty of reasons that says that there is a certain lack of coordination worldwide. Not everywhere, of course, as we will see later, but there is it's still a very complex multinodal problem with plenty of players. It's quite difficult to achieve worldwide coordination. High cost of repositioning. The short-term benefits sometimes quite difficult to see. It's more the long-term on a global scale that can actually be calculated. And market volatility and disruption. You're gonna have peak season. You're gonna have Cyber Friday. You're gonna have Christmas. You're gonna have Panama Canal. They're gonna be dry. You're gonna have some events in the world that are gonna actually change the way you usually do business, and that will require you to be more agile. And it could be as simple as a bad weather forecast or a strike in one of the ports. So I think the tariff war that happened is just one more example of event. And as you know, most of you know, of course, there's been an escalation of a tariff war between the United States and the Popular Republic of China. And the fact that there's been a tariff war, it's let's say in a different date, and that the number were changing, keep on actually sending different signal to the shipping line, keep sending signal to actually customers, and keep on changing agenda almost on a daily basis if you follow the news. Has been quite challenging for the shipping line. They had to adapt. They ended up sometimes with blank sailing, with some boats with not enough containers to make it profitable. They decided to redeploy fleet. For example, from the route from China to US, there have been some of the boats have been redeployed to more profitable trade lanes like Asia, Europe. But 3 days later, there is a change of tariff war in the tariff war. Sorry. So, but it's too late. Part of the fleet has been redeployed. There have been the customers that are actually booked suddenly a lot of transportation very suddenly in order to fulfill their demand or to protect their interest for 2025. There have been plenty of small changing like that created surpluses. For example, the US West Coast, the massive surplus of empty container. There are sometimes a lot of events, except the trade war actually created more events than usual, and had a huge impact on the empty container repositioning, the need, and of course the impact on the freight rates. So we have some report on the impact on the repositioning. A lot of shipping line publish actually some suspension on entire service loop. Hapag-Lloyd reports 30% drop in Trans-Pacific booking. So yet a huge impact, and they start to be more and more documented and published. That's very good. So now that we talk about the presence of a need for empty container repositioning is not going to change. We presented the key drivers. We presented the challenges for shipping line and other players in the industry. We're going to talk about solutions. There are different parts of solution: operational, collaborative, and of course the one that are interesting for us as a technological solution. From an operational point of view, there have been plenty of smart moves that have been done in the world in order to limit let's say the moving of vehicle. It could be truck or it could be vessel on the ocean empty, whether it's in an empty container or it's just like a truck going to a depot without any containers in order to pick up one. There's been a lot of work done on the ports to try to create hub ports. There's been an effort to actually collect and aggregate information from different players. Collaborative platform that start to emerge. First, to be able to share, for example, share containers, creating some marketplace where you can actually buy some container capability at different places in the world, Singapore being one of them. And real-time visibility platform. Now, if you go on the web right now, you could, if you spend money, get access to the trajectories, the historical log, the real-time position, sometimes of a lot of vessels on the sea, in order to use it in your business. Next, and I think that's the big part of what is done today, if you want to do it, if I may say, from your computer. A lot of effort is made in demand forecasting based on machine learning. So how using historical data, how using some signal on the market, I will be able to forecast the demand at different locations and in terms of size in order to reposition my empty container correctly. Data sources that are become more and more common and accessible. Also, it could be the weather forecast. It could be some feed on news in order to analyze possible strike. It could be a port API that give you data on the congestion and timing to dock. Network optimization, of course, and simulation. Which is funny about network optimization is despite all the advance of AI the last, let's say, 3 to 4 years, network optimization rely on mathematical optimization for quite a long time. And it has been actually proven in some part that using network optimization actually benefit quite a lot the port. So this is why we actually choose it at TetriXX. Power of simulation, of course. ECR decisions are very complex. There are a lot of variables, and we're going to see in the next slides all the variables, all the parameters, all the constraints that we are taking into account when it comes to reposition. And they, of course, occur at high cost. Simulation allows us to run a lot of what-if scenarios. And make no mistake, shipping lines are already repositioning their containers. Unfortunately, there is a big discrepancy. Some of them are actually using very modern algorithm to reposition. Some of them are actually doing it using email and telephone and their own Excel spreadsheet, trying to calculate. And then sometimes it's very local. I'm responsible for Bangkok. I'm responsible for Phnom Penh, and I do my own repositioning based on my empirical knowledge on the boats and on the different players. So it's quite, but once the repositioning is done, the shipping line are actually looking at everyday event, trying to evaluate if the current event is impacting their current repositioning. If a boat is late, if I do my repositioning on Monday, but Wednesday I learned that one of my vessels is going to be late by 3 days, what is my immediate consequence of my surplus and inventory in terms of empty containers? So yes, of course, simulation as most of you will know, will help us validate cost saving, identify bottleneck in advance, and ensure my ROI. At Box23 is a solution we provide to shipping lines and other players. 100% mathematical optimization. We want to satisfy 100% of the satisfy of demand, and we want to provide to the shipping line using our solution cost calculation on the repositioning we offer and CO2 report. We are very happy to run in 1 minute on the 2000 repo and offer the possibility to run the algorithm several times by changing the input. What we did at TetriXX is we model 15 business rules to match data versus reality, of course, and we program our algorithm to run on an horizon of several weeks. Normally, 4 weeks is a good one, and we respect the wish of the shipping line. They want to focus on the use of their own ship. They want to use some partners or some feeders to actually transport their containers. Let's have a look at all the different constraints we have. Of course, I don't know why my screen has been blocked. Apologize for that. Of course, the first one that we look at is the supply and demand. The first thing is how much supply do I have in all the ports of my network, and what is the demand? The first data we are looking at is the capacity of each boat that I have in my armada. How much room do I have left to transport empty containers in all these boats that have been scheduled? Ports have limitation on the number of empty containers they can actually store. They come also with the cost. They have limitation in terms of day and number of days and in terms of quantity. Some of the containers that require special transportation, in particular when it's come to refrigerated one. So as you can see, we have a list of constraints that we took into account into our algorithm. We ingested them, we processed them, and some of them are more important, and we of course got to learn along the way. We run the Box23 algorithm, and we offer to the customer visual dashboard in order to see their cost saving, in order to see the result of the optimization, in order to compare different scenarios I may have run, and of course providing some reports on the scope 3, which is the transportation of goods. Our algorithm rely on today, can read it differently, but today our algorithm rely on the fact that we want to satisfy demand. This is our first criteria. And we focus of 10 container types, knowing that 4 of them are the most important. And once we have satisfied demand, we're going to try to minimize the cost. Cost can come from storage cost. It can come from the cost of using a partner or another feeder to transport my containers. Try to minimize cost and to find an integrated solution to approximate the previous solution. We did a POC with an open source solver a few months ago. Of course, it took quite a long time to run, and the resolution of problem and sub-problem just by looking at Southeast Asian region and all their port and location was too slow. We had the opportunity to work with Gurobi, which is a commercial solver, and we started to run the entire APAC region in less than 5 minutes. And the problem and sub-problem resolution time became negligible. So we are very happy of our partnership with Gurobi, of course. when you look at the map, in order to visualize the complexity, the different ports, the different trajectory. I don't know if you see it correctly, but you have sea, but you have also trucking. I give you an example in Vietnam. You cannot move from one port to another in order to protect their trucking industry. You actually have to take the road, so you really have to take that into account in your optimization. Which is quite important, is we need to provide the shipping line a dashboard, really a global dashboard per country, per location, how much actually the algorithm is actually helping them at increasing their empty container capability and respond to their demand. But at the same time, we need to improve locally every single port. We need to prove to the operator of every single port. Like for example, as an example in Ho Chi Minh, that the algorithm is actually reducing the need for is providing empty container where it's actually needed. So on the left, you see without any optimization. On the right, you see with optimization. We'll finish with this conclusion. Empty container positioning is vital for the maritime efficiency. Data and technology drive ECR success today. And there are plenty of solutions. It could be IoT by putting some IoT dongle on some of the container. Could be collaborative digital platform, and we can see that benefits are realized. More and more ports and companies are using modern technology in order to reduce cost, to produce. I will say in the supply chain, everything is in the flow. So we need to provide faster and more reliable deliveries, and more visibility, always more visibility. And this is where we at TetriXX, a data company, we aim to provide a better analytic, of course, better optimization, but to some extent, every single of our projects become with a data transparency and data visibility for what kind of data you already have. Let's start with that, and let's work on it and make it even more visible. There is still not a widespread ECR adoption. Sometimes it's just a cost. So there are a lot of investments that will have to be done in the shipping industry in terms of course, data, collaboration, and investment in modern technology. One slide about our company. TetriXX, we build a solution using artificial intelligence and mathematical optimization for the supply chain. We believe there is a lot of work to do in the supply chain in order to modernize, even if the journey has started. It's a long road. And of course, everything starts with data, governance data, acquisition. We like to bring our expertise. Some of them have been working in the supply chain for more than 20 years and are really happy to see the new technology helping us and modernize this industry. And of course, anything we can do to help company reduce the CO2 emission is a gift to the world, and this is the core of what we do at TetriXX. Thank you very much for your attention today, and I will take any question if there is. Thank you very much.
All right. Thanks so much, Jean, for that excellent and informative session. So now comes the fun part, which is our Q&A session. So thanks to everyone, to those attendees who have submitted their questions. So let's take a closer look and provide the answers you've been eagerly awaiting for. So let's get started. So Jean, we have first question for you, and it goes, can you share some examples of cost saved by optimizing the movement of empty containers, like age cost savings achieved.
You're on mute. Yeah.
Alors, cost saving achieved. Cost saving achieved. A very good question. How can I actually talk about it without giving too much number? Let's have a look. We did a POC with a company, and roughly they have a certain budget for repositioning in terms of millions of dollars for repositioning. And what I can say is we actually, with our algorithm, only use a quarter of this budget to actually reposition using the in the APAC region. So we for the data that we have, our repositioning algorithm suggested something which is a quarter of what they were to use. The cost of repositioning is a sensitive subject. We really have to look at all the numbers to really estimate it. But definitely, as soon as you avoid using an entire ship, an entire vessel just to transport empty containers, you actually work.
All right, that's great. Thank you so much, Sean. So I think that's something our audience can take away and chat down for the reference. So we move on to our next question, and that question is, what are some of the simulation cases that you do? Is it mostly demand variation cases?
Thank you very much. No, it's not demand, only demand, which is quite a very important part, actually. The different scenarios that we do are part of different categories. The first one, yes, could be demand. The second one will be changing of vessels ETA at the port of loading or port of discharge. So we actually run a first repositioning, let's say on a Monday, on a 4 weeks repositioning, and on a Wednesday we receive a list of boats and a change of vessel schedules. This is how we actually simulate it, and then we need to recalculate and see the impact of the change of schedules. That's formed by the change of schedules. That's also the reason why actually the company are actually working a lot on predictive analysis based on other sources than their own source of ETA for the boats. They are using other source trying to evaluate is my vessel going to be late. Also, we actually one of the simulation is the number of days needed in some of the port to unload the container and reload it. Two different cases: to unload it from one ship to another, transshipment, or just to unload it and to load it on a truck. There's definitely something that we play with. The number of days, like roughly is 2 days for transshipment, 3 days for others. What happened is in this port, actually, because of congestion or because of a strike or because of weather, this number of days actually change. This is the kind of a simulation we are doing. I think we are. And also, some of the simulations that we do is what if the boats decide not to stop at the port. If you arrive on a port, it's a complete change of schedule in the what if scenario that we simulate. What if too much congestion in a port and the vessel decide to pay penalties, but not to deliver the containers and not to be able to load empty containers and just go to the next step, because there is no way it's going to be able to make it at this port in the next days due to constraint, strike, congestion issues, COVID.
All right. Well explained, Sean. So that clarifies the topic. So for our next question, we have here, which algorithm have been applied to address the problem and what optimization models have been used?
Okay, and for that, we'll have to discuss on a silent NDA, dear Sri Candela. But it says there are a lot of it's quite difficult to answer that in a webinar which is recorded.
No worries, Sean. So
Read a little.
So we can always take this offline. So if to our audience, if you needed actually more, if Sean needs more time to really go through in detail, we'll be happy to get in touch with you offline. So moving on, we have here another question. Are empty containers moved from surplus to deficit location along with laden ones? And how it works for liners? Sorry, Sean. So
Thank you very much. I was reading the question also on to make sure I understand correctly. Alors, today, I just want to make sure I understand. The empty containers are actually loaded. What we do in our algorithm is we consider vessel movement, and we also consider inland movement when we have data about the inland movement through trucking or through rail. So an empty container is actually moved along the other ones, along the other containers on the vessels. So if Parta Barma could precise a little bit, but they are just considered another container. Maybe, yeah.
all right, there we go. So for our audience to keep in mind moving forward. So we have here a few more questions for you, Sean. So we have a very interactive set of audience for today, and you guys have been sending us very interesting questions. So we appreciate that. So for your next question, and what are the empty containers move? Oh, sorry, this one is already done. So are the challenges of empty containers movements seasonal, or say during holiday season? Does it aggravate?
Yeah, it's a very good question. I will say that, of course, season impacted, but considering that the volatility of the market right now, it seems we are always in a status of changes. So usually we had some seasonality in the because of Christmas, because of shipping of goods. But that if you look at the last 5 years, COVID suddenly created a huge change. Okay, people were ordering all the time. There was massive import in the US and some congestion in massive congestion on the port in China. And I think what is always very frustrating when we talk about this issue is the specialists explain to you all the time that a small congestion somewhere can actually create a ripple effect across the entire shipping line. We need to solve the problems that we can solve in front of us. And today, we can see that the industry is really trying to be more agile, not only to reply to a seasonal demand for my Cyber Friday or my Christmas, my Thanksgiving, but more for to be able to react to a geopolitical event like the attack in the Suez Canal, the dryness of the Panama, the tariff war, COVID. I mean, if we look at the last years, the change of seasons is is not only weather.
Okay, great point, Sean. So this highlights the key points perfectly. So I think that's a wrap for our Q&A session. So thank you all for your great questions and of course for your active participation. A big thank you to Sean, and we truly appreciate your insights and thoughtful responses. Your expertise really added a lot of value for today's discussion. So to our audience, we thank you for staying engaged throughout the webinar. While we maybe couldn't address all your questions live, we'll be following up with you with an answer. So we'll be in touch with you. Also, a recording of this webinar will be shared through your email shortly. So Sean and team, before we officially wrap up, any final insights, reminders, or announcements that you'd like to highlight? Please go ahead.
Thank you very much. I would like to thank everybody and of course Gurobi for the opportunity. I see plenty of questions and people that are very interested in the subject. Feel free to contact TetriXX for the next step in your journey in optimizing your need and solving supply chain challenges. Thank you very much.
Yeah, and thank
All
you so
right.
much for taking the time, Jean. Appreciate your presentation. And yeah, there was some interesting chat in the comments about collapsible containers and these sort of things. So definitely have a read. And yeah, it's cool. Thanks everyone for joining.
All right. Thank you, Stephen. So, yeah, well, thank you once again to everyone for being with us today. And we hope that you found this insightful session and wishing you a great day ahead. So until next time, bye for now.